Hello dear kids, do you know about these two friends, Tom and Jerry? Have you ever seen them? Okay, well, and do you like to watch a video of these two, Tom and Jerry? Yes, here you can.
Autopilot engaged. Gravity engaged. Gravity disengaged. Gravity engaged. Gravity disengaged. Engaged, disengaged, engaged, disengaged, engaged, disengaged, engaged, disengaged, engaged.
Okay, what happened to Tom in the video? Yes, do you know why it has happened? And do you know about gravity? So, in this video we have seen two situations. First one, what will happen if there is no gravity? And the second one, what will happen if there is gravity? Good. And let's think about our atmosphere. The blanket of air that surrounds the earth is called atmosphere. Yes. Do you know what keeps the atmosphere at its place? Yes. This is what we discuss now, gravity. Good. So the atmosphere is hurled around the earth due to the earth's gravitational pull. So in this chapter we are going to discuss about the composition and structure of our atmosphere. And now we will move further, that is composition of atmosphere or air. See, as we discussed earlier, the blanket of air that surrounds the earth is called atmosphere. Good. See, the atmosphere consists of a mixture of gases, water vapor, then dust particles, pollen grains, and many impurities like smoke, salt, and other chemicals are present in varying quantities in the atmosphere. See, the main constituent gas or gases are nitrogen, oxygen, and other gases. See, nitrogen consists of 78% and oxygen is 21%, and other gases, that is remaining 1%, is made up of gases like carbon dioxide, then argon, hydrogen, helium, and ozone. Yes. Now we will move to the next topic, that is structure of the atmosphere. See, the atmosphere extends approximately up to 1600 kilometers above the surface of the earth. Okay. So the density of the atmosphere is maximum near the earth's surface. Okay, so this is so because the gravitational pull is strong near the surface and the upper layers of the atmosphere rest upon the lower layers. So as we move further away from the surface, the air becomes thinner and thinner. Important, as we move farther away from the surface, the air becomes thinner and thinner. Therefore, out of the 99% of the total mass of the atmosphere, which lies within the height of 32 kilometers and the first 6 kilometers contains the 50% of the total mass of the atmosphere, and the 49% is found within the height of 6 to 32 kilometers. So the remaining 1% is found above the 32 kilometers. So the atmosphere is divided into 5 layers based on composition, temperature and other properties. So starting from the surface of the earth, the layers are called troposphere, stratosphere, mesosphere, thermosphere and exosphere. So the layers vary in thickness. Remember, these layers vary in thickness. So let us learn about the first layer, that is troposphere. So this is the lowest layer of the atmosphere. Troposphere is the lowest layer of the atmosphere. It extends to a height about 8 kilometers, up to the height of 8 kilometers at the poles and about 18 to 20 kilometers at the equator. Here you can see. Okay, so the next, it is the densest part of the atmosphere. Very important. Troposphere is the densest part of the atmosphere, and some dust particles, water vapor and other impurities are found only in this layer. Very important. Dust particles, water vapor and other impurities are found only in this layer. Then all weather phenomena such as clouds, fog, then rainfall, snowfall, storms and lightning occur here. Okay, so in this layer, the temperature of air, listen carefully, in this layer the temperature of air decreases with increase in height at the rate of 1 degree for every 165 meter. Very important. In this layer, the temperature of air decreases with increase in height at the rate of 1 degree Celsius for every 165 meter. See, this is called normal lapse rate. This is called normal lapse rate. That means the decrease in air temperature at the height of 1 degree for every 165 meters, and this is known as what? Normal lapse rate of atmosphere. Okay, so as the troposphere is the lowest and the densest layer of the atmosphere, it absorbs maximum heat radiated by the Earth's surface and thus keeps the Earth warm. So here, troposphere is the lowest and the densest layer of the atmosphere. It absorbs maximum heat radiated from the Earth's surface and thus keeps the Earth's surface warm. Good. So our next layer, that is stratosphere. This layer lies above the troposphere and extends to a height of about 50 kilometers. Okay, so the tropopause is the narrow boundary that separates the stratosphere from the troposphere. Remember carefully, the tropopause is the narrow boundary that separates the stratosphere from the troposphere. You can see here, this is what? This is what? Tropopause. Okay, so the tropopause is a narrow boundary that separates the stratosphere from this troposphere. So in the lower part of the stratosphere, the temperature remain constant. Okay, in the lower part of the stratosphere, the temperature remains constant. In the upper part of this layer, there is a great or gradual increase in temperature. So here you can see this is just because of the presence of ozone layer. Okay, and the next, there are virtually no clouds and very little dust and water vapor in this layer. Okay, virtually no clouds and very little dust and water vapor can be seen in this layer. And one more thing, convection currents of air are also absent, so are also source of weather phenomena. Okay, and one more very important thing, the stratosphere contains ozone. The stratosphere contains ozone which absorbs the harmful ultraviolet radiations of the sun. Okay, so the stratosphere contains the ozone which absorbs the harmful ultraviolet radiations of the sun. And our next layer, that is mesosphere. This layer lies above the stratosphere and it extends to a height of about 80 to 85 kilometers. Okay, so the narrow boundary that separates the mesosphere from the stratosphere is called stratopause. So here the narrow boundary that separates the mesosphere from the stratosphere is called stratopause. And in this mesosphere, the temperature of air decreases with increasing height. Very important. In the mesosphere, the temperature of air decreases with increasing height. So when meteors enter the Earth's surface from atmosphere or from the space and reach this layer, they burn due to friction. So when meteors enter the Earth's atmosphere from the space and reaches this layer, they burn due to friction. And now we are moving to the next layer, that is thermosphere. Okay, the fourth layer of our atmosphere. So this layer lies above mesosphere and it extends up to a height of about 690 or 450 kilometers to 690 kilometers. Here temperature increases rapidly with increasing height. Very important. In thermosphere, the temperature increases rapidly with increasing height, and the boundary between the thermosphere and the mesosphere is called mesopause. The boundary between the thermosphere and mesosphere here is called mesopause. This layer contains electrically charged particles called ions. Okay, so in thermosphere, what we can see, the electrically charged particles called ions. See, these particles reflect radio waves back to the Earth's surface. It reflects the radio waves back to the Earth's surface and enable us to have wireless communication. Okay, and the thermosphere is also called the ionosphere. Why? Because of the presence of ions. So thermosphere is also known as ionosphere because of the presence of ions. And our last layer, that is exosphere. The fifth layer of our atmosphere is exosphere. The uppermost layer of the atmosphere is called exosphere. It extends to a height of about 1600 kilometers. Okay, here it is written 10,000. So it's 1600 kilometers and gradually merges with interplanetary space here. Okay, so this layer is extremely rarefied. It's extremely rarefied and very light gases like hydrogen and helium are found in this layer. Okay, so this layer is extremely rare field, and very little gases like hydrogen and helium are found in this layer. Good. Now we are going to discuss the most important part of our chapter, that is the significance of the atmosphere. The significance of the atmosphere. See, the components of the atmosphere are useful to us in various ways. Okay, so the first and foremost, nitrogen. Nitrogen is required to maintain the fertility of the soil and is vital for plants. It is vital for plants. Then, atmosphere contains oxygen, which all living beings need in order to stay alive. And the next, carbon dioxide helps plants to produce food in the presence of sunlight. And it also keeps the earth warm by absorbing the heat radiated from the surface. Then ozone. Ozone protects us from the harmful ultraviolet rays of the sun. So, the water vapor in the atmosphere causes precipitation. You have already learned it. Then, the dust particles form the nucleus for condensation, which results in the formation of clouds, and that cause rainfall and snowfall. And I want to share something more, that is, what is greenhouse effect? A greenhouse is a large room made out of glass, which is used for growing plants. Okay, so the glass walls allow sunlight to enter during the daytime but prevent the heat to escape at night. So the heat thus gets trapped within the greenhouse and makes it warm. So it is useful for growing plants in cold places. Then greenhouse effect is the effect produced by carbon dioxide and water vapor in the upper atmosphere, which raises the atmospheric temperature by trapping the heat radiated from the Earth's surface. And carbon dioxide is therefore called greenhouse gas. Carbon dioxide is called greenhouse gas. Other greenhouse gases are methane, chlorofluorocarbons, and nitrogen oxides. So, in recent decades, the amount of greenhouse gases present in the atmosphere has increased due to the burning of fossil fuels, factory emissions, etc. So, this has resulted in an increase in the average temperatures on Earth. So, this phenomenon is called global warming. So, it causes melting of glaciers, rise in sea levels, changes in the amount of rainfall, and changes in agricultural yields. So, you can watch the video related to the effects of global warming here.
Human activities, from pollution to overpopulation, are driving up the Earth's temperature and fundamentally changing the world around us. The main cause is a phenomenon known as the greenhouse effect. Gases in the atmosphere, such as water vapor, carbon dioxide, methane, nitrous oxide, and chlorofluorocarbons, let the sun's light in, but keep some of the heat from escaping, like the glass walls of a greenhouse. The more greenhouse gases in the atmosphere, the more heat gets trapped, strengthening the greenhouse effect and increasing the Earth's temperature. Human activities, like the burning of fossil fuels, have increased the amount of CO2 in the atmosphere by more than a third since the Industrial Revolution. The rapid increase in greenhouse gases in the atmosphere has warmed the planet at an alarming rate. While Earth's climate has fluctuated in the past, atmospheric carbon dioxide hasn't reached today's levels in hundreds of thousands of years. Climate change has consequences for our oceans, our weather, our food sources, and our health. ice sheets, such as Greenland and Antarctica, are melting. The extra water that was once held in glaciers causes sea levels to rise and spills out of the oceans, flooding coastal regions. Warmer temperatures also make weather more extreme. This means not only more intense major storms, floods, and heavy snowfall, but also longer and more frequent droughts. These changes in weather pose challenges. Growing crops becomes more difficult. The areas where plants and animals can live shift, and water supplies are diminished. In addition to creating new agricultural challenges, climate change can directly affect people's physical health. In urban areas, the warmer atmosphere creates an environment that traps and increases the amount of smog. This is because smog contains ozone particles, which increase rapidly at higher temperatures. Exposure to higher levels of smog can cause health problems such as asthma, heart disease, and lung cancer. While the rapid rate of climate change is caused by humans, humans are also the ones who can combat it. If we work to replace fossil fuels with renewable energy sources like solar and wind, which don't produce greenhouse gas emissions, we might still be able to prevent some of the worst effects of climate change.
So dear kids, we can have a recap of our chapter in the form of a mind map. So this is our chapter, Composition and Structure of the Atmosphere. In this chapter, we have learned about the composition of atmosphere, then the structure of atmosphere, and the significance of atmosphere, and a few more things, that is greenhouse effect and global warming. Let's see the first one, composition of atmosphere. The atmosphere consists of mixture of gases, then water vapor, dust particles, pollen grains, and many impurities like smoke, then salt, and other chemicals are present in varying quantities in the atmosphere. Like nitrogen, it is 78%, and oxygen is 21%, then other gases is 1%. And also we discussed about the structure of the atmosphere. It has 5 layers: troposphere, stratosphere, mesosphere, thermosphere, and exosphere. So first one was troposphere, and starting from the surface of the earth, the layers are called troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Okay, these layers vary in thickness. So about troposphere, what we have learned, this is the lowest layer of the atmosphere. Then it extends to a height of about 5 kilometers at the poles and about 18 to 20 kilometers at the equator, and also it is the densest part of the atmosphere. Then dust particles, then water vapor, and other impurities are found only in this layer. And next one was stratosphere. So this layer lies above the troposphere and extends to a height of about 50 kilometers above the surface. And next one was mesosphere. This layer lies above the stratosphere and it extends to a height of about 80 to 85 kilometers above the Earth's surface. Then thermosphere. So this layer lies above the mesosphere and extends up to the height of about 450 kilometers to 690 kilometers. Then here the temperature increases rapidly with increasing height. The temperature increases rapidly with increasing height. And our last, it was exosphere. So the uppermost layer of the atmosphere is called exosphere. It extends to a height of about 1600 kilometers and gradually merges with interplanetary space. And also we discussed about the significance of the atmosphere. See, the components of the atmosphere are useful to us in various ways. So the first one was nitrogen is required to maintain or provide fertility to the soil and is vital for plants. Then atmosphere contains oxygen, which all living beings need in order to stay alive, and carbon dioxide helps plants to produce food in the presence of sunlight, and it also keeps the surface warm by absorbing the heat radiated from the surface. And ozone protects us from the harmful ultraviolet rays of the sun. And also we learned about the next greenhouse effect. A greenhouse is a large room made out of glass, which is used for growing plants. The glass walls allow sunlight to enter during the daytime but prevent the heat to escape at night, and the heat thus gets trapped within the greenhouse and makes it warm. And our last topic was all about global warming. In recent decades, the amount of greenhouse gases present in the atmosphere has increased due to the burning of fossil fuels, then factory emissions, etc. So this has resulted in an increase in the average temperature on Earth. This phenomenon is called global warming, and it causes melting of glaciers, then rising in the sea levels, changes in the amount of rainfall, and changes in agricultural yields. So these all what about our chapter. So stay home, stay safe. Bye bye.